Hello everyone, welcome to a supplemental video for Math 5. In this video, we will try to determine the domain of a function if the function is a radical function given as follows. In determining the domain for this function, we need to find for the intervals for which this radicand becomes non-negative, or in other words, greater than or equal to 0. Doing so, we can apply different methods, but one important method that you have learned in your grade 8 math is the method of table of signs. In the method of table of signs, what you need to do is to look for the values at which the factors of the radicand becomes 0. Therefore, we need to equate the numerator to 0, and this implies by factoring that x minus 3 multiplied to x plus 2 is 0, and x becomes 3 and negative 2. Meanwhile, for the denominator, x minus 1, this is quite simple, and we see that x equals 1. Now, the method of table of signs require you to create a table. And of course, the entries of the table would be the factors of your radicand. The factors of your radicand will fill out the rows, and let me write it as follows. X minus 3, x minus 2, x minus 1, and of course, the final product, which is x squared minus x plus 6, x minus 1. This is the radicand that we are interested in. And since this is a table, let me create some lines. The first line will be treated as the real number line. And this will be subdivided based on the zeros of the factors that we have just obtained. And of course, we're going to do this in an increasing manner, where we begin it, of course, with negative 2, 1, and then 3. We look at the first factor, x minus 3. X minus 3 is 0 at x equals 3. For the numbers to the right of 3, for example, 4, 5, 6, or whatever number that is found on the right side of 3, we see that when we evaluate or simplify it to x minus 3, that gives us a positive value. And for the numbers that on the left of 3, for example, 1, negative 2, then factor x minus 3 simplifies to negative values. We apply the same procedure for x plus 2. Its 0 is found on negative 2. And on the right of negative 2, we see that this becomes positive. And on the left of negative 2, this results to negative. Meanwhile, for x minus 1, its 0 is found at x equals 1. On the right of that number, we see that the expression simplifies to positive values and negative for the left of that number. Now, let me put an emphasis on this before we proceed on the next step. It is not always the case that the positives are found on the right and the negatives are found on the left. For example, if we consider a factor of negative x plus 1, this expression negative x plus 1 still has a 0 on x equals 1. However, if we take values on the right of 1, say 3, this simplifies to negative 3 plus 1 or negative 2. Therefore, this results to negative values. And on the left of x equals 1, you can easily check that this becomes positive values. See, it's not always the case that if it's on the left, it's going to be negative, and if it's on the right, it's going to be positive. Do not assume that that is always the case. For example, if you have a factor of x minus 1 quantity squared, its 0 would still be here. And on the right side, you see that it is positive, and on the left side of 1, it is always positive as well. And so, the lesson for this part of the video is that do not assume anything. Please do and apply the methods properly. Okay, now let us proceed on the last row. We just need to determine the sign based on the signs written above. For example, 3 negatives result to negative. 2 negatives result to positive. 1 negative results to negative, and no negatives result to positive. We also see that at x equals 1, this becomes undefined. Meanwhile, for the numbers negative 2 and x equals 3, this becomes 0. Going back to our original goal, we need to look for the interval at which this becomes greater than or equal to 0. Therefore, those interval would be from negative 2 up to 1. However, 1 is excluded, and then from 3 up to positive infinity. Thus, we write our conclusion as follows. Therefore, the domain of f would be from negative 2 up to 1, inclusive of negative 2, exclusive of 1, union 3, inclusive of 3, up to positive infinity.